All right, on the next example, it says now graph the following functions: y equals x squared, and then 1/2 x squared and 1/5 x squared. So let's go to y2, and instead of 2, let's change this into 1/2, and then x squared, and let's change this one into 1/5 x squared. Now let's hit graph and see what happens. So blue line is what we started with, then red line is the next one, then the black line. So we can see that it started out the regular length, got wider, and this one got wider. So, and each time the coefficient just got smaller, because 1/5 is smaller than 1/2. 1/2 is smaller than 1. So as the coefficient gets smaller, the parabola widens. So it would go from the regular one to a wide version. Now, let's look and see how the table changes. We already got the graph. Let's go to the table. Second graph. At -2, we still had 4, 1, 0, 1, 4 from the regular one. From the second one, from the 1/2, which is the red line, we got 2, 1/2, 0, 1/2, and 2. And from the other one, we got 4/5, 1/5, 0, and then 1/5 and 4/5 again. So let's see what happens each time. Well, from the blue one to the red one, from 4 to 2, this is half the size of that, right? From 1 to 1/2, that's half the size of that. So each time, the y values are once again multiplied by a factor of the coefficient. They're all 1/2 the original size. But once again, the vertex is still at 0, 0. It didn't move. Other than that, all of our other y values are 1/2 the size of what they started. Now, let's look at this one, 1/5. What do you think happens with these y values? Well, it goes from 4 to 4/5, 1 to 1/5, 1 to 1/5, 4 to 4/5. Each of these values is 1/5 the size of the other one. So our y values, once again, are multiplied. Oh, sorry, this one should have been the coefficient 1/2. By a factor of the coefficient 1/5. So all of these are 1/5 the original. Now, whenever something is getting smaller in parabolas, we call that a shrink. So both 1/2 that size and 1/5 that size, those we call a shrink. We'll do one more on this video. It says, now graph the following function, x squared and negative x squared. So go back to y equals. Let's erase these other ones. Our first one, we needed it as x squared. Our next one, we just put it as negative x squared. Hit graph. And we see that all this does, it looks like the same graph. It just looks flipped on top of each other. So let's look at the table value change. So second graph, pull up the table. We've got +4 for our original, and then it goes to -4. -1 goes to -1. Or sorry, +1 goes to -1. 0, 0, still the same. 1, -1, and it goes from 4 to -4. So as you can see, all of our y values are just the negative version of what the y values were over there. So we've got the same vertex, and then your y values just change signs. Now, just as a side note, their value, or the absolute value to be technical, remained the same. Because all that happened was they changed signs. So like, look, 4, -4, 1, -1, 0, 0, 1, -1, 4, -4, 9, -9. Any value it had for y on our original, it's going to have the same y value, just going to be a negative sign. I'll stop the video here. We got one more.